So let us now discuss how can we solve this problem. Maximum difference between increasing elements. Given a zero indexed integer array nums of size n. So given a array of size n, find the maximum difference between nums I and nums j, that means nums j minus nums I, such that 0 is less than equal to I less than j is less than n, and nums of I is less than nums of j. Nothing but here I'll be initializing something like I should be here and there should be j here, right? J should be here, and I need the maximum difference I can get by changing the values of I and j. And I should be less than j, should be less than n, and 0 is less than or equal to I. Now return the maximum difference, right? If these are the differences that I can get, maximum difference between nums I and nums j, right? Return the maximum difference. If no such I and j exist, return -1. Let us see. Now I'm just initializing the maximum difference to what I can get. The maximum or the minimum that I can get is negative infinity. So if I get even one or in negative values, then also I'll be considering, right? So let us take this example 7154. What I'll do is I'll just initialize I first, right? Nums j and I, right? So I should be less than j. So let me initialize I here. Let me initialize I here and j here. I is less than j, j is less than n. Now let's see. Is nums of I less than nums of j? That should also be considered, right? Nums of I is less than nums of j? No. So let me just go to the next index, right? Let me just delete it firstly, right? So I'm going to the next element for this j. So my j is here. Now I is 7, j is 5, right? Nums of I should be less than nums of j. So does this condition satisfy here? 7 is not less than 5. So let us go to the another index 4, right? Less than 5, right? Now 7 is less than 4. No. Let us go and increment our I pointer here. I got I here and my j starts from I plus 1. Now is 1 less than 5? No. Let us just skip it and go here. Now, nums of I is less than nums of j. At this moment of time, I can consider 5 minus 1 till now 4. So 4 is greater than negative infinity, right? Let us increment our j pointer, right? Now I got j as nums of j as 4. Now nums I should be lesser than nums j. So here 1 is less than 4, which I'll get 4 minus 1 will be 3. So from 4 and 3, 4 is the maximum. Now let us increment our I pointer, then I'll get 5 and 4. Is 5 lesser than 4? No, it is false. So the maximum till now I got is 4. Now let us go to the next example 9432. Let me initialize I and j here. Now nums I should be less than nums j. Then only I'll just consider max difference. Now max difference initially is negative infinity. Now I got j, right? 9 is less than 4? No. Now let me initialize increment the j. Now 9 is less than 3? No. 9 is less than 2? No. Right. Now 4 and 3. Is 4 less than 3? No. Let me increment j pointer. 4 is less than 2? No. 3 and 2. I incrementing this I. 3 and 2. Is 3 less than 2? No. So the maximum difference is negative infinity. So here I'll return -1. And if I use these two pointers I and j and go through for a loop with I and for loop for j, then I'll end up in big O of n square time complexity. But Can I even reduce it? Now, let us see. I need the maximum difference. So why not get the max element every time, right? Now the maximum element should be at the right and the minimum element should be at the left. Now I need the maximum element, I need the minimum element, and the maximum element should be at the right. Maximum element should be at the right and minimum element should be at the left. Now if I initialize this as my max element and I go till from here, I go and update the maximum element every time I go and initialize the maximum element every time or change the maximum element every time. Now let us see how. Right now I got something like, let us see, after that when I got here the maximum element will be 5, right? Now after that I'll go to 1. Now 1 is lesser than 5. 1 is lesser than 5. Now what I'll do is consider this difference. So let me write something like, for let me initialize max element is nums of n minus 1, where n is size of nums dot size. Now for I is equal to n minus 2, I'm just starting over here from here, right? Let me just get this out, right? So I'm just starting over here, right? So I am starting here and I will change the max element every time. But before that, let me initialize max difference. Max difference is equal to negative infinity. Now I is equal to n minus 2 and I will be going from I is greater than or equal to 0, I minus minus. Now my I pointer is here. The max element is 4 now. If nums I nums I is less than max element, then only consider max difference. Max difference is equal to y. Nums I less than max element. Why I am just considering only when nums I is less than max element. We are said that nums I should be less than nums j. Nums j, instead of nums j, I am just using max element, right? So if nums I less than max element, then max difference is maximum of maximum of max difference, comma, max element minus nums of I. Now there might be a case that here 5 is the maximum element from 4 and 5. So I'll update the maximum element here. So max element will be maximum of max element, comma, nums I every time. So this is how you get, and at the last let me return max difference, or I'll return maximum. I'll tell you when. If max difference is equal to negative infinity, then I didn't get any maximum difference. So I didn't met any condition like this. So this condition is doesn't met. Nums I is less than nums j. So that's why I am returning -1 there. So this is how you solve this problem. And if you have any doubts, please comment in the comment section. And I have given the code link in the description. Go and check it. Thank you for watching this video. Do like, share, and subscribe to my channel. Thank you.